Hello everyone. In the last video, we have already discussed a bit about logistic regression. So there we have discussed about the hypothesis. So what is our hypothesis for logistic regression? Our hypothesis is y equal to sigmoid of theta naught plus theta 1x, or we can think of it as y equal to sigmoid of line equation, or hypothesis of linear regression. Okay, so this is what we are trying to do. And why are we doing this? Because in case of linear regression, we'll be having a range of minus infinite to plus infinite, which is not interpretable in case of binary classification. That's why we are using some function called as sigmoid, with which we are merging the range from minus infinite to plus infinite to 0 to 1. So this is the idea of using this particular sigmoid, and this will be our hypothesis. I hope everyone has a clear idea about hypothesis, loss function, and optimizer. If you don't have the idea, please refer to the linear regression video. I'll be putting the links in the description so you can check it out. Now let's continue with this particular logistic regression. This is the example that we are discussing. So based on the average number of hours studied in a week, we wanted to predict whether the person will fail or pass. So this is our problem at hand. And if you are drawing some straight line which can give anything between minus infinite to plus infinite, that's why what we are doing, we are using this sigmoid function and making it into range of 0 to 1. Then how will my sigmoid curve fit it? My sigmoid curve will fit something like this. How will the graph of sigmoid will be looking like? So let's say this is x and this is sigmoid of x. Then my graph will be adjusted like this. Like here it is minus infinite and here it is plus infinite, and the maximum is 1 and the minimum is 0 in this particular y-axis. So like that, my sigmoid function curve will look like. And here also we are having something such kind of S-shaped curve over here also. So here it is like 0 for most of the points, and after that it is going on to 1 for most of the points. Like there are some errors, like for these points it is not giving correct answer. It is predicting it as 1, but actually it's 0. So like that, there are some points which we cannot predict well, but for most of the points it is covering, right? So that's why we can use this particular hypothesis. Sometimes and how will this particular hypothesis will change? So basically this curve, this S-shaped curve can be like this, or like this. It can be in several ways. And how this shape of this S-shaped curve will change, that will be changed based on these particular theta naught and theta 1 values. And what are these theta naught and theta 1? These are called as parameters. Okay. So if you are not familiar with all these things, you need to refer to this particular linear regression video. So please check it out. If you don't know, like if you don't understand any of these things that I'm discussing, okay, there I have clearly told what are parameters and what are hyperparameters, and like how this curves will change according to these parameters and all those things. So if you check that and come here, it will be very clear for you. So this is our hypothesis. And what will be our next step after hypothesis? In any of the machine learning algorithms, the next step will be the loss function. In case of linear regression, we used a loss function that is mean squared error. But in case of logistic regression, we can't use that particular mean squared error. The reason being, if you think of mean squared error, how error on one particular data point will be calculated, it will be calculated something like this. So it will be y minus y cap whole square. So this will be giving us the error on one particular data point. And here, what is this y? This y is the actual value, whereas this y cap is the predicted value. So like this, we'll be getting the error on one point. Now let's see how this particular loss is varying with respect to the difference in actual and predicted value. So let's say we are trying to predict something like price, and our actual value for price is, let's say, 5,000, and y predicted price is 5,005. Then what will be my error according to mean square error? So my error will be y minus y cap whole square. That will be 5 square minus 5 square. Okay. So minus 5 square will be 25. So do you think this particular error that it is making is very significant or very high? Basically, if we are thinking about price for such kind of feature, 5 is very small difference, right? This is not a very significant difference, and we can think that it predicted correctly or the model predicted correctly. Even for such small difference also, the amount of error that we are showing over here is 25. And similarly, let's take a little higher error, like like it is 5000, whereas the predicted value is 5100. Even this 100 error is also not too high, right? So if we think individually, the error like 5000 and 5100, the error is not too much, but the amount of error that the mean squared error is showing over here is too high, right? It will be 10 power 4, which is very high. So even for such small difference also, the amount of error that it is showing is too high. But whereas if we think of binary classification, like there are two classes of outputs, right? So one is 0. So actual output can be something like 0, and let's say actual output is 1. So when actual output is 0 and the predicted output is 1, what is the amount of error that mean squared error will be making? The mean squared error will be making an error of 1, that is 0 minus 1 whole square. And similarly, when its actual value is 1 and the predicted value is 0, what is the error that it is making? It is also 1 minus 0 whole square. And similarly, if it is 0 and 0, then what is the amount of error that it is giving? It is 0 minus 0 whole square. And when it is 1 and 1, it is giving 1 minus 1 whole square. So when it is getting correctly predicted, the amount of error that it is showing is correct only. It is showing 0 in this case. But here, if you observe, it is showing 1. When this is the worst that can happen, right? In binary classification, instead of predicting it as 0, if it predicts it as 1, then that is the worst prediction, right? So for such worst prediction, it is giving an error of 1. Whereas here, this is actually good prediction only. Instead of predicting it as 5000, it is predicting it as 5100, whose values are nearby. So this we can say some good prediction only. But even for that, the amount of error that it is giving is 10 power 4, right? But here, if you observe, for this y actual and y predicted, the difference is 1 over here. That's why we are giving an error of 1. But actually, if we see realistically, if we think of the binary classification problem, instead of predicting it as 0, we are completely doing the opposite. So the ideal error should be plus infinite, right? And similarly here also, the ideal error should be plus infinite. So we need to find such a function whenever these two match, like whenever these two match, it should be giving an error of 0. Okay, and whenever these two doesn't match, like this 0 and 1 are not matching here, and 1 and 0 are not matching here, in such case it should give plus infinite. And mean squared error is not satisfying that condition, right? So that's why we should be moving on to some other loss function. And now let's discuss the loss function that we'll be using. So let's divide the loss function into two parts. So the first part is when y equal to 1. Okay, so y equal to 1 means the actual output is 1. In such case, whenever my y predicted is also predicting it as 1, then the loss that it should be giving is 0, right? Because both are equal. And similarly, whenever the predicted output is 0, when actual output is 1, the loss that we expect is plus infinite. So can you guys think of any function which takes this y cap as the input, and it should be giving output respectively? Like whenever the y cap is 1, it should be giving it as 0, and whenever y cap is 0, it should be giving it as plus infinite. So can anyone think of such function? Like here, f of y cap. So this function should be giving 0 when y cap equal to 1, and this function should be giving plus infinite when y cap equal to 0. So just think it and write down in the comment section. Now I'll be discussing it. So the function is minus of log y cap. So do you guys know what is log 1? Log 1 is 0. This we all know. And what is log 0? Log 0 is minus infinite. But here we expect it to be plus infinite, right? So that's why we are keeping minus on both these cases. So now minus log 1 will be 0 and minus log 0 will be plus infinite. So this is exactly giving the outputs that are required for us. That is 0 in case of y predicted as 1 and infinite in case of y predicted equal to 0. Whenever y equal to 1, the loss function that we can use is minus log of y cap. And similarly, now let's think of the second part, that is y equal to 0. Whenever y equal to 0 and y cap equal to 1, then what is the loss that we are expecting? The amount of loss that we are expecting is plus infinite. And similarly, whenever our actual output is 0 and the predicted output is also 0, then the loss that we are expecting is 0, right? So now can you guys think of any function which will take y predicted as the input and will be outputting 0 when y cap equal to 0, and similarly it will be outputting plus infinite when y cap equal to 1. So this also like write down in the chat, think, pause the video and write down in the chat. Now we'll discuss it. Such function is minus log of 1 minus phi cap. So what this 1 minus phi cap will do, whenever we are passing this 0, it will be giving 1 as input to this function, that is minus log, which will be giving 0 as output. So when y cap is 0, and similarly whenever we are giving 1, it will become, this will become 0, and minus log 0 will be giving us infinite. So this is working as expected, right? So whenever y is 0, the function that we can use, the loss function that we can use is minus log of 1 minus phi cap. But this is not right thing, right? When y equal to 1, we are using some other loss function, and when y equal to 0, we are using some other loss function. It should be looking like some formula, right? It should not be looking like some if else condition. Here it's like some if else condition. When y equal to 1, do this, and when y equal to 0, do this. So let's try to combine these two. On combining, we'll be getting our loss function for logistic regression. What are the inputs for the loss function? The inputs for the loss function are actual output and the predicted output. So based on these two values, we'll be having one formula. In case of mean square error, the formula is like y minus y cap whole square, right? So here, the formula should be combination of these minus log y cap and minus log of 1 minus y cap. How we'll be getting that? We can do something like this: minus y times log of y cap and minus 1 minus y times log of 1 minus y cap. Okay. So this is our formula for loss function, and let's see how this is working. Whenever y equal to 1, we are expecting the function to be log of minus log of y cap, right? So let's see whether we are getting minus log of y cap when y equal to 1 or not. So if we keep y equal to 1, here we'll be placing 1, and this portion will become 0. So if it becomes 0, this whole part will be insignificant, right? So this formula will be equal to minus log of y cap, right? Because this is 1 and this whole thing will be 0, and the remaining thing that we are left with is minus log of y cap. So this is what we are expecting when y equal to 1. And let's see the same when y equal to 0. So when y equal to 0, the loss function that we expect is log of 1 minus y cap. So let's see we are getting this minus log of 1 minus y cap or not. So when we keep y equal to 0, this will become 0, this whole portion will become 0, and this will be 1. So we'll be getting our loss function as minus log of 1 minus y cap. So this is what we are expecting, right? Like that, our loss function will be working. Okay. So this we can call it as log loss, or we can call it as binary cross entropy as well. So this is our loss function in case of logistic regression. Actually, this is not the exact loss function. We'll be doing average. This whole thing is calculating loss on only one data point. And this, what is this n? This n is the number of training data points. On all the training data points, loss will be calculated, and then we'll be considering the average loss as the loss of the whole model. So this is what we'll be doing it in the loss function. And now let's observe the graph of it. Okay, let's try to see this graphically. So if you think of log of y cap and y cap, that means for this, how the graph will be looking like. So whenever y cap is 0, what it will be outputting? It will be outputting something as plus infinite, right? Because minus log of 0 will be giving us plus infinite. So that's why whenever y cap is 0, that means whenever it is over here, our curve will be over here. And whenever it is 1, it will be at 0. That means it will be over here. So the curve will be looking something like this. So it will be connecting this 1 and 0, something like this. So this is our minus log y cap curve with respect to change in this y cap. Okay. So, and why is that happening? So this happens because whenever log 1 we are having, it will be outputting 0. And whenever log of 0.1, which is same as log of 10 power minus 1, and it will be giving us 1. So for suppose, let's think it is base 10 for our simplicity. Okay. So then it will be giving 1. And whenever it is log to the base 10 0.01, then it will be how much? It will be 2. Like that, we'll be getting, like we'll go so on till infinite. Like that, we'll be getting infinite at 0 and 0 at 1. So this is our curve of this minus log of phi cap. Now let's check this minus log of 1 minus phi cap as well. So this will just work in the reverse way, right? Whenever it is 0, it will be outputting 0. This output of this minus log y cap will be 0. And whenever this is 1, it will be giving output as plus infinite. That means it will be giving over here. So it will connect these two. It will look something like this. So this is the curve of minus log of y cap. Sorry, minus log of 1 minus y cap. So for this, if we give 0, it will be giving log 1 and it will be outputting 0. So, and similarly, whenever we give y cap as 1, it will be outputting plus infinity. So, and this is how this graph looks like. Now, our loss function is a combination of these two, right? So here if you observe, this is one part and this is the other part. So sometimes this will get activated and some other times this will get activated. So overall, if we see the curve of our loss function, so let's say this is our loss function, and like here our loss function will change something like this. So till some point it will change like this. It will come from plus infinite to 0, and after some point it will follow the other loss function and it will go from 0 to plus infinite. Like that, my loss function will be looking something like some u-shaped curve. Okay, so this is my loss function with respect to the thetas. Actually, thetas are the parameters. Okay, so if we change these theta values, it will be affecting the y cap, and based on that we will be getting this particular graph. So like this, our curve will look like. And what is the third step and the last step of any algorithm? So the third step is our optimizer. So in case of linear regression, what optimizer we have used? We have used something called as gradient descent, and here also we'll be using the same gradient descent optimizer, that is theta nu equal to theta old minus alpha times loss with respect to the theta. So this will be the same loss function. And what this will be signifying? This will be signifying the direction in which the theta value should move. Let's say this is theta naught and this is the loss function. And how will my curve of loss function will look like? My loss function curve will look something like this. And for this, let's say initially my loss is over here. So this mathematically it will be giving a slope, but for our understanding purpose, we can think of it as giving, it will be giving us direction in which it should move. So basically our loss is very high, right? It should be moving on, like it should be moving over here. So here my theta not optimal will be present and the loss is minimum in this case. So this is the minimum loss that we are getting in this case. So this should slowly converge to this. That means it should be giving us the direction in which this particular theta value should move. So whenever my initial theta is over here, as the slope is negative in this case, it will be giving negative value. So this negative and this negative will multiply, and it is like telling to add something to the theta old. So that means this is our old value. For this, we are adding something, and our theta value is moving like this. Like that, here we'll be having some other loss. So this is second time loss calculation. So again, our loss is little higher. So again, it will be giving some negative value, and again we'll be moving like this. Like that, we'll reach till theta optimum. And what is the time that is required for this is called as convergence time. So these all things we have discussed in linear regression. We are discussing quickly once again. This is about the gradient descent algorithm. So in gradient descent, what are these thetas? These thetas are our parameters. And what is this alpha? This alpha is learning rate, or this can also be called as hyperparameter, because we will be adjusting these hyperparameters. And who will adjust these parameters? These parameters will be adjusted by the model. So I think that's it for this video, guys. I hope everything is clear. If it's not clear, please check the linear regression and come on to this. I'll recommend watching you that particular two videos which I have mentioned in the description. So please check those linear regression videos and then check it. Then you'll have clear clarity of all things that I'm discussing. I hope you liked the video. So please like, share, and subscribe. Thank you everyone. Bye bye.